Okay, so the main point of this field exercise, whenever we have our lab day, is to, number one, practice field procedures for setting and measuring a control network. Number two, practice collecting and interpreting the data that you collect. And then number three, learn how to perform adjustments on the data. So really, this step is what we'll be focusing on the most. You can maybe get to this one on the field day, review your stuff, make sure you have everything you need. This last one, though, you'll be working with this data in the lessons as we move forward through the weeks. Okay, so what you need to do is set up a simple control network. We're going to have an outer loop that's closed, and we're going to have an inner point for some redundant measurements. And the redundant measurements part will be with our least squares adjustments. So what we need to do is set 4 points. It doesn't have to be overly huge area to work in. And then an interior point. We need known elevations and coordinates on at least 2 of these points to create a reference line. So if you have 2 points in a network that you can work with, you can use those. If you want to use GPS to shoot in these 2 points, or whatever 2 points in your network, that's fine. You can use that information to get going. Okay, so once we have these points set, you are going to need to run your instruments through it. So we're going to start off talking about the level loop first. So let's say this is one of the points that you measured in, you got an elevation. So we're going to call that your benchmark. You need to run an outer loop through the points and close it. But then to get redundant measurements on the inside, we're also going to need to run an interior loop. So perhaps you decide to run a loop like this, and maybe you do a loop like this. So that's our leveling. That's how that needs to be done. Moving on to our traverse, let's say we have those known points that we started with here. So that was a known point, and this is a known point. This is going to create our known reference line. So we're going to occupy one of these points and backsight the other one to get started. These are our known points. Then we're going to traverse our way around the outer part of this loop. So while you're set up here, you may decide to go ahead and do your foresight on this first point and turn 2 sets of angles, direct and reverse. 2 angle sets, direct and reverse measurements. So we're going to aim in direct mode, take a measurement, turn to the foresight, take a direct measurement, flip the scope, aim it back, reverse mode, turn, reverse mode. In all total, you should have 4 angles when you're done. Okay, so let's say we've turned in this angle. While you're set up here, if you want to go ahead and turn a set of angles into this interior point, you can do that. You do not have to occupy the interior point. We just need to measure it 2 times from any of the other points around the traverse. All right, so we've got that setup done. You're going to tear down and move forward. So you're set up here. Now you're backsighting here. We're going to foresight to our next forward control point. And while you're set up like this, if you want to go ahead after you've turned this one in, turn in a set of angles to that one, you've now completed the requirement for the 2 measurements on the interior point. So you will tear down, move forward, occupy, backsight. We're going to turn this point in. It looks like it's closed because we have lines connecting, but in order to do these adjustments, we need 4 angles turned. So if you remember, we started over here we have one angle that we turned when we started, and we also have one to there. Then we move the instrument. We had this angle that we turned, and we have this angle. You move the instrument, and you have this angle that you turned, but you are going to need to set up one more time up here so that we can get this angle as well. So you will set up a fourth time on the last point. You'll back sight down here, and you will turn your angle to foresight one more time. So this is going to result in really 2 lines measured through here. This is how we get the closing information. We'll get linear closure information and also angular closure information. So this is how this field work needs to be done. I'm going to take a minute here and look at an example that I have. So this has been provided in the course site. It shows, similar to what I just demonstrated with the sketch, but it also shows your sample field notes. So for the traverse, you should have, occupy, back sight, foresight numbers. You don't have to do instrument heights and rod heights for your traverse. That's because you're getting elevation data with your automatic leveling or your digital. Well, I prefer automatic level, actually. No digital allowed. Okay, so anyways, if you're going to write these down or organize your data later, it might look similar to this. So we've got our exterior traverse points all the way around, 1, 2, 3, 4. And then on this side, I just included the 2 while I was set up interior points to point number 5. For your level loop, your leveling notes here, you should have 3 sets of collected information for those level loops. So this is the outer one where you went all the way around. This is one of the interior ones, and this is the other interior one that hit on point 5. So if you've decided to use a data collector to store your data while you're doing the traverse, you're going to have to pull some information out of the survey report or the raw survey file, depending on what kind of brand you're using. This is an example of a Trimble survey report, and the key things we want to identify to make sure we have the right stuff. You should have 2 points that you type in and start with. So you're either using 2 points that you already know, like here on Benson's, we have 2 campus control points that we already know the information for, so those have been plugged in. Or if you've used GPS to shoot in 2 starting points, you can type those in or keep working with the same job file. But we need those 2 point numbers to start with. So the next thing you'll want to pay attention to is what your occupied points are. So in this case, our station setup, we were at station 2. Our backside point was point number 1, and we foresighted. So our first backside direct horizontal angle, we foresighted point number 3. So similar to direct reverse measurements that you would write down by hand, that's what this is doing in the surveyor's report or the survey report. So we have our backside direct angle, foresight direct angle, flip the scope. We have our backside reverse angle, our foresight reverse angle, flip the scope. We have our backside direct angle, foresight direct angle, flip the scope, backside reverse angle, foresight reverse angle. You don't need all of that information individually. It's already been measured and stored. What you do need is the average angle at the end of all of that. So look in your report. This is where you're going to find the average angle out of those 4 that were turned. So you'll need to pick that out. Now, one thing most data collectors or survey reports or raw files are going to report your horizontal distances as slope distances, and we're going to need these as horizontal distances. So what I would suggest you do is when you have your data collector there with you, use your COGO inverse function and just inverse, for example, from point number, for occupying point number 2 here, foresighting point number 3, you just inverse from 2 to 3, and that will give you a horizontal distance that you can write down once the point is stored at the end. So for example, back to these field notes, this was without a data collector. If you're going to use a data collector, what I just showed you, that average angle is what you need to get out of there. And then if you do that COGO inverse, you'll get this average horizontal distance. But we need average angles and average distances at every occupation point around the outside of the traverse and also to the interior point from 2 different locations.